Hey everyone, it's Becky, and today we're taking a look inside the Belkin Autotracking Stand Pro. Keep watching to see me try it out, take it apart, and analyze the design and manufacturing of the circuitry inside. This video is sponsored by DigiKey, which carries tools for your own teardowns as well as some of the components in the device's circuitry. Head to the link in the description for more info on all the parts we could identify. Let me know what I should tear down next in the comments. So here's the Belkin Autotracking Stand Pro. It's got a simple but solid design. Snap your phone into the MagSafe connector and the stand automatically rotates to track you. Belkin was kind enough to send me two of these, one to take apart and one to keep using. It's a cool piece of tech and the first product to use Apple's new DockKit accessories standard. Previously, products like this would be limited to capturing with their own apps, but now the DockKit system allows the stand to seamlessly integrate with the native camera app while capturing content or during video calls. It's also got a battery inside, which makes it portable. It's got a tripod mount on the bottom. It only charges the iPhone when it's plugged into wall power though. To do its thing successfully, it has to move super smoothly and quietly, so I'm curious what's going on inside. The first step of taking it apart is to remove the sticker on the bottom, which hides some screws. But this thing is a super awkward shape, so to keep it flipped upside down, I placed it over the edge of my table. Removing the bottommost piece of plastic reveals the first of two circuit boards, connected to the rest of the wiring through this free rotating slip ring, which allows it to spin 360 without tangling any wires. After removing a few more screws, the main body of the base came free, revealing a large, heavy bearing to support that smooth rotational motion. After unplugging the wire connected to the NFC antenna, I was able to remove the top body plastic. Then I cut the zip ties holding the battery in place and unplugged all the wires from the nearby connectors. Next, I unscrewed the first of two stepper motors. This one was connected to the base through a gear situation, controlling the rotation. The other motor is still stuck behind the upright piece. At this point, I was able to remove the first circuit board, the slip ring, and that really big bearing. Continuing on, there were a few bolts with anti-slip nuts holding onto the second stepper motor, and a few screws connected to the upright piece. Inside this long neck is a belt that was driven by the second stepper and some more wires. Without the metal shaft, the remaining MagSafe charging pivot top bit looks like a combination between the Star Trek Enterprise and a Sentinel from the Matrix. Inside the pivot point is another bearing, a small circuit board, and wires leading to the magnetic charger. Taking a look at all the parts, you could reuse a lot of these in other projects. Two perfectly good, quiet stepper motors, a slip ring, two bearings, and a battery. Score! Now it's time to take a closer look at the electronics inside with my channel's favorite electrical engineer, David Craner.
How's it going, Becky?
Good. You are being watched.
I'm being watched? Oh.
Come sit down. Oh, there it is. Oh, and you can bring it over to me. Hello. This is what we're taking apart, David.
Wow, cool. What is it?
It's the Belkin Autotracking Stand Pro with DockKit, the first official accessory to use this Apple's new protocol for peripherals to use the camera input.
Neat. So it can... Wow, that's very cool.
I guess previously this type of thing existed, but you'd need to use its own app, and now you can use the native camera app.
Mm-hmm.
And you can do it vertical also.
This is like if you're like running around the room and want to stay on the video call.
It's for the TikTok dances, David.
It's for the TikTok dances, yes.
Yeah, so that when you do like a cool breakdancing move, like you're not out of frame.
You don't go out of frame. Yeah, it's important.
Like the guy on the box.
Oh yeah, look at him. Yeah, he's not making manual camera adjustments in that posture.
But also I think it's cool for like cooking videos or things where your hands might be dirty.
Yeah.
And I like that it works both horizontal and vertical, portrait and landscape.
Yeah.
And it also is a phone charger when it's plugged in. So it's like I've just been using it as a dock for my iPhone even without the camera jack in.
Yeah.
But see how it's
cool.
battery powered.
Yeah, I like
so it's got a battery in it. It's obviously got 2 motors because it's moving side to side and up and down.
It's very quiet.
It's
when it
super
moves.
quiet.
Motors are quiet. Oh, come back. There it is. Grab me again. And it only tracks people faces, right?
I think so. I haven't read that it does anything else besides people. It uses, you know, whatever the Apple tracking is using, just people. But you can use it on the back-facing camera too.
Oh. Oh, it remembered.
Uh-huh.
Wow. Okay.
Yeah, so it's fun, right? And that has this button on the front. You can turn off the tracking and just use it like a regular phone stand. Yeah, and you know, it's MagSafe and all that
Magnetic mount.
Yeah. So
Cool.
Belkin was kind enough to send me 2 so that I could have the one to demonstrate to you, and then
destructively analyze one.
This one.
Wow, it's a lot of parts.
One for using and one for Becky Smash.
Yeah.
So I actually would like to show you, like, this is a monster pile of parts.
Belt drive.
We usually do wearable things, so this is kind of big for us.
Yeah.
But why don't we look at the scan first?
Let's look at the
because
scan.
as a pile of parts, I don't think it really shows off like all of the cool engineering features, and I want to show them to you and have you be excited to touch that belt again once you learn what it's doing inside. So Lumafield 3D scanned it with their CT scanner, and like, look at all of the stuff in there, right?
Stuff.
There's like, here's a motor, here's a battery, here's the MagSafe.
It's a full-on robot.
It is a full-on robot. There's a bearing down in here, gigantic bearing, and then like a bunch of different screws. And then Lumafield also prepared us some PCBs back and forth. I think this one was really interesting. The plastic removed. So this is the bottom motors, the battery, and the 2. You can see both of the PCBs, or you can see just one of the PCBs right here. This is the PCB. And there's 2 PCBs. You can see both of them. This one down here and this one here. But yeah, you can see the motors and all the screws and the wires. All nice and packed in there, really. It's got a nice weight to it, right? But the bearing right at the bottom.
Nice density, yeah.
Here's the bearing.
I like a good bearing. Oh yeah, nice. So smooth.
So smooth. Well, this one's never been used.
Yeah. Then this is motor.
Yep. So there's 2, what are those, stepper motors?
I think steppers.
I think so, because when I looked up the chips, they were stepper. I mean, they look like steppers. And then they each have a gear on the, or like this one has a gear and this one has, what is this called when it's a belt drive thing? It's also a gear.
I don't know.
It's the thing that the belt.
Yeah, the thing the belt goes on.
Thing the belt goes on.
Is it a sprocket? Maybe. I'm sure someone in the comments will tell us.
Tell us what it is.
Yeah.
And then, let's see. Look at these bookmarks. So this is the belt connected to the motor. So this motor at the bottom, the shaft faces out the back of the device, and the metal bit goes up here, and the belt wraps around that belt mount attachment on the motor and goes up through the shaft. But look at how it...
Is it twisted?
Yeah, look at it twist 90 degrees.
Oh, interesting.
From like around the back of this motor and then up, and it's...
I see. So that
90.
saves some hardware from having to put gears that like interlock and...
Yeah, so it has like a right angle twist to the belt drive, which doesn't hurt the belt at all. The belt isn't like churning over and over again like it would on a motorcycle. It's just going back like back and forth. So it doesn't need to traverse the whole length.
Yeah.
It's pretty cool, huh?
That is pretty cool.
I thought that was really clever. And yeah, you can see it really clearly in the scan, the way that the belt twists. Yeah, this is something I never would have noticed if not for the scan. Like while taking it apart, I wouldn't have even noticed that the belt was right angle to the motor. Because when I took it apart, you know, like the motor's detached and then you don't see how it was attached anymore.
Not attached there anymore.
Okay, so do you want to start looking at the circuit boards? We have the 2 motors.
There's a lot. What do you think?
Sure. Let's start with the first PCB. That's the big guy. There was a can over this area. You can see
where it was mounted.
Yeah, where's my pointy tweezers? You can see the edges of the can was here, and I used my hot air rework station to very easily take that off. And then, oh, surprise, surprise, what's underneath besides our friend, our dear friend.
What is it? What is it, Becky?
It's our friend, the Nordic NRF 5340.
53. This is a 53 series. Interesting.
So this is a dual-core Bluetooth 5.4 SoC with Bluetooth LE, Bluetooth mesh, NFC, Thread, and Zigbee.
What's Thread? I've never heard of Thread.
I don't know. I have to look it up. So that's our friend. This is our per episode daily stock tip to tell you that Nordic Semiconductor is a publicly traded company, and we see their parts in literally
a lot of stuff.
Every single thing we take apart.
Mm-hmm.
So
very popular.
That's my hot stock tip. Nordic Semiconductor. So that's the Bluetooth chip, and why do they have cans again?
To keep electromagnetic interference from escaping.
Or from getting
in.
And is it fair to say that these motors and their supporting circuitry cause a fair amount of electromagnetic interference?
That is probably true. That can definitely happen.
Right. Moving on.
What are these giant electrolytic capacitors for? Are those just like for...
Well, there's two of them, so that makes me think it's... and they're both close to those motor driver chips.
What values are they, I wonder? Can I peel this up?
Yeah. I'm not going to try to put it back together. I already mangled the MagSafe connector.
25 volt, 47 microfarad. So it's not huge, but it's
the fact that there's two of them and they're each close to the motor driver chip, like the other motor driver chip is on the other side right there.
Yeah.
Makes me think that they're related to the motor. Can you show the motor driver chip on the
Here's
microscope?
one motor driver chip, and you can see it's got these big ol' sensing resistors next to it.
What are sensing resistors?
So often when you want to like determine how much current is actually going to something, you have to like measure how much current is going to it. And one way of doing that is you put a resistor in the current path. That's enough to provide like a measurable voltage drop between the input and the output of the resistor, and then you measure that voltage drop across the resistor, and then from that you can math out how much current was actually going through it. But because these are sensing for driving current to motors, that's going to be like a lot of current. So that's why these resistors are much larger physically
Chunky
than
boys.
the other ones. Yeah.
What's that footprint called? That's a big footprint.
That looks like a 1206 to me.
And there's our motor driver, and our other motor driver chip, which is on the other side of the board, also has those beefy friends. All right, so mystery solved. There's this like through-hole component sticking up off the board. Why can't I get it under the microscope?
This thing?
Oh, there it is.
Where is it?
It faces up. It's a Hall effect sensor.
I see.
I looked it up.
Oh, that's probably for like position feedback.
Yeah, because like where are you, or like how many times around? If it has a magnet in it somewhere, which it must, to line up with that, it's going to be able to sense like that it's gone all the way around.
Right.
With the Hall effect sensor, and that's probably why it sticks up like that. And anyway, when I've done like a spoke POV bicycle project, like this is the same way you set up the stick it straight out, and it's kind of vulnerable to getting whacked on your bicycle, but not so much inside this package. All right, moving along.
Well, then they have this little, I'm looking at the, okay, this is the Nordic chip over here. Yeah, and so this connector was probably under the can, but this is probably used for like debugging, because like if they don't want to be, if they want to be checking like the signals that are going out the antenna, this is just a place where you can just like plug straight in and see. So, moving along to our next chippy chip. Let's see, we got this. Do you have any idea what this big guy is? Could be an inductor. Is it? I think it's in its own little... It is. It doesn't have any exposed wires. Like this looks like an inductor to me because it's got that like coily look to it. Looks like it's got something wrapped around it. What all things is it next to? And there's another one over here too, under your...
Yeah, there's two. Oh, there's two, which makes it has something to do with the motor.
They have different values.
Oh, they do? Okay, then maybe it doesn't have something to do with the motor. This chip...
Can we see into these in the X-ray?
Yeah, we can. This chip, MPPS, is...
MPPS.
It's the fully integrated synchronous 30-watt boost converter with pass-through mode and programmable switch current limit by Monolithic Power Systems. So that's managing the battery charging, yeah? Boost converter, 30-watt boost converter.
It could just be for managing like all of the power going to it.
3 boost converter with pass-through. Okay, yeah, because when this is plugged in, it charges the phone, and when it's not plugged in, it doesn't charge the phone. So is that what that means by pass-through mode?
A boost converter will just... I'm not sure what their implementation of pass-through mode means, but like boost converter in general will basically just like take a lower voltage and convert it to a higher voltage, but at a steady rate. Also, I think that these are inductors because the label on the silk screen is an L.
And that's typical for...
Yeah, that's inductor.
Here they are on the PCB.
L2.
This is them, right? Here and here. Here and here.
Maybe.
Squares with circles inside them. That are just as tall as the can.
Inductor. Yeah. That could be a coil inside
Yeah,
there.
it looks like a coil. I mean, this is the other one that looks like what it is.
Right.
So I think, yep, they look like they're coily inside.
Yeah. And it says L2 and L9. Is that do I see a threaded insert at the top?
Yes, for the tripod mount.
Love threaded inserts.
I didn't bother taking it out.
Threaded insert is a top tool.
Yeah, it's cool. It's because this whole thing can sit on a tripod.
Yeah. Especially if you're doing home 3D prints and stuff like that. Like,
yeah. Here you go, look.
Heat set threaded inserts are great.
That's a coil if I ever saw one before.
That's an inductor. Oh, well, that's this one.
Is it?
That's this one, I think. Because then you can see the box there and the box there.
Okay, so I can't see into the box in this particular view, but we can see it.
What's in the box?
We can see it here on the cross section.
Yeah. Yeah, it looks like an inductor to me.
As far as the other side of the board...
Also, boost converters, you often find inductors nearby. Yeah.
On the other side of the board, there isn't much. There's another one of those motor chips. There's a bunch of connectors. There's a few LEDs here. 3 together, LED...
So tiny.
I know, really tiny.
Look at them.
The silk screen says what, LED?
6, 3, and 4.
6, 3, and 4. And this thing has a couple of light pipes on it. One is here.
I see.
For the front, like whether it's tracking you or not, light. And there's one on the back for if it's charging, I think.
That looks pretty good.
Yeah, doesn't it? But it changes color, and that's why there's 3 LEDs here.
Oh, interesting. So they didn't do one RGB LED; they used 3 discrete LEDs. And then the light pipe touches all of them, and then they just choose. Yeah.
Yeah. So that middle one is the white one, and then I think there's a blue one and a red one.
Oh, they use a tau glass antenna.
Or green when it's tracking.
I've used that company before for patch antennas.
So what's going on there with that antenna on the piece there? It's an NFC tag, and it's used for pairing with the iPhone.
I see.
Only. Like once you pair it with the iPhone, you don't use that NFC tag again. But that's part of the dock kit standard, is that it's really easy pairing with the Apple devices. You just put the iPhone near this NFC tag, and it like connects like magic, and everything works. So Carlos, my buddy who hooked me up at Belkin, he let me know about this in advance. He's like, there's one piece that you're going to need to unplug as you take it apart in order to not rip it, and that's this NFC tag. So when I took it apart, I was able to find this plug, fix the scan also. I looked at the scan before I took it apart.
Oh, look, they do the same thing with the 3 LEDs down here, too. There it is again.
Yeah, sometimes it's just cheaper, and then also you don't have to like PWM them to blend the colors or anything. You can just... It'll be what it'll be.
And then what's this? This header, I see some signals names. I see some signal names that I recognize, like SCA, SDA, SCL.
SCL, that's I2C, right?
Yeah, this is where you would start if you were trying to do software hacking on it, probably.
So this board is driving the motor, powering the motors, and has the switches and LEDs. Oh, there's one switch on this board.
Yeah.
Are you ready to move on to the second circuit board? This one sits closer to the bottom in the, so if we go to the scan, you can see it. It's closer to the bottom here, and that one we just looked at is like kind of in the middle. So on this side, there's like nothing except the connectors. There's a little button. Beep, beep, beep.
Where?
There.
Oh, there it is.
That is the, I think that's the tracking button that you press to like start tracking and stop tracking you.
Yeah.
I think it says that on the other side, actually. There's like a label. So I don't think I like figured that out by myself. I think I read this text that said tracking button.
Oh yeah, it literally says tracking button, yeah.
But that's the only thing on that side of the board. This
It's nice
side,
that they labeled it with like human readable names of things. You don't see human readable names of things on circuit boards very often. It's
USB-C one. There's the USB-C port. Then it's got, this is the chip on this board. It's the CPS8852 Child Protective Services. This is made by a company called Convenient
USB
Power.
Power delivery chip.
Power delivery controller IC.
I see. So that's so that it can charge real fast.
Charge the battery and charge the phone.
Yeah.
So that's why we need two different power chips. One's probably for powering the...
Like the boost converter, a 30 watt boost converter in this, because it's 30 watts, that just tells me like this is, without looking at the rest of the board, but if I just see like a big old boost converter like that, I would think that that's like, this is conditioning the power for like everything.
Okay, so here's the battery. It looks suspiciously like an 18650. Is that the exact size of the 18650s, or are they a little longer than that?
Well, we can measure it. Because 18650 is the measurements.
Is the measurements of the outside of the battery, right?
Gone.
So this bottom circuit board really only has
5,000 milliamp hours.
The USB port and this power chip, and then the connector for.
Does that connector fit onto?
No, everything plugs in. Like the battery plugs in, the motor plugs in somewhere. You know, like so. Find something with the right. Here you go. It's for the slip ring. That's what I wanted to talk to you about. This connects to the slip ring. So the bottom circuit board and the top circuit board spin independently of one another.
The component that...
So there's a slip ring in the middle that allows for that.
Cool. So this spins, but the wires all stay in the same place.
Yeah, and that connector there is that.
Can we look inside of this?
I could show you the product page. When I worked at Adafruit and we started carrying these, we like cut one open and took photos so that you could see how it works.
That'd be interesting.
We can look at it on the scan though, because we have the scan of this thing. Base, scrub left to right. Yeah, okay. Thank you for these handy bookmarks. So here's the slip ring here, right?
Oh, it's back.
Oh yeah, you're right. There it is. Yep, there it is. Sorry, that's it right there. Here.
So how do they? What are they on the inside? Is it just like however many tracks that are concentric, and then there's like a brush that sits on it or something?
Yeah. See how there's like one sort of channel for each of the wires.
Right.
And like one set of wires is connected like on the inside of that tube, and the other set is connected on the outside. And yeah, there's like a brush that moves.
Cool.
Yeah.
It's a cool thing.
It is a cool thing. I've never seen it used in a product like this. Like I don't think I've ever seen one used in a product. Period. But then again, you don't really think about this kind of thing. It's like, oh, the top spins independently of the bottom.
You don't realize how annoying and hard it is to design that until you actually start trying to design something with it.
Exactly. And then this giant bearing is really fun.
I like giant bearings.
Definitely reuse that for some project.
Yeah. It's a good like fidget toy.
Yeah. Here's a cross section of the motor. That's the motor in the back. And then what is?
It's cool that the thing is so quiet. I know that.
Here's the bearing on the inside. Look, you can see the balls.
I looked up the data sheet. Oh yeah, look at those balls. Great looking balls. I looked at the data sheet of the motor driver, and it definitely has a lot of special features for keeping the motor quiet. Because you know, like stepper motors have problems with like whining and like making sounds, especially when they're like speeding up or slowing down or just like sitting in one place, but the coils are engaged. You can hear them hum.
Yeah, yeah, like my 3D printer. You're never lonely when you have a 3D printer around.
Yeah, exactly. But this is really quiet, and it goes to the level of the component selection that they chose for the actual motor driver. Like you can tell it's something that they really cared about during the design process.
I think the whole product shows that everybody really cared about it every step of the way, because it works really well, and there's like no extra space anywhere. It just looks like everybody worked really nicely together.
The lights light up, but they're not like irritating in your face. Yeah.
That's what I would expect from Belkin.
Yeah, Belkin does a good job usually.
But I'm still impressed, even them having such a fancy reputation. I'm still impressed by this thing.
Yeah.
There are a couple of other little circuit board things I wanted to ask you about.
Oh, baby.
To see if you understood what was going on. This thing goes up the neck and exists right at the top of the. It's like near the MagSafe charger.
Okay, so maybe we should be using this to illustrate. Where is it on this?
It's here.
Uh-huh.
And it has these two wires coming off of it that went to another tiny circuit board that just has this switch on it.
Only that switch?
Yeah.
Okay. Probably just because they want it. It's probably just a sensor for like, is the phone attached?
Is the phone like being attached, or is the phone being, because it like does stuff when you connect the phone besides just charge it. It like also starts to do the tracking and see if the camera app's open and stuff. So that I know is a switch.
It shouldn't need a physical button for knowing if there's a phone on it if it gets data through here.
Oh, it's the Hall effect sensor reader?
It could be a Hall effect sensor.
Or is it a magnet? Because there's already a Hall effect sensor. Here's the Hall effect sensor. Is this?
Well.
But why would we need another one up here?
Well, this one's down here.
Oh, wait a second. When you plug in the phone, like the magnetic field becomes stronger, right? Because it starts charging it?
No, it should be pretty contained inside of the coil.
So
maybe the Hall effect sensor senses, because does the iPhone have a magnet in the back of it?
Yes, the MagSafe ones. Yes.
So maybe that's what it's sensing. Maybe that's the thing that actually senses to see if the phone is there.
Nearby. So this whole circuit board is all about, is the phone docking or undocking, or
it could be.
And we need two different ways to tell that. We need the magnet sensor and we need the switch, apparently.
Maybe it could be a positioning thing. Like maybe there's a way to like put the phone on where the switch is clipped, but like the MagSafe isn't aligned right or something, and this would tell you if it's in the right place. Maybe I don't know.
No, it doesn't really stay on the thing unless the MagSafe is engaged.
Right. So this is like, it's like this.
Yeah. See in the scan.
Yeah.
And then only the two little power wires go to the switch
doesn't
here.
this tilt up and down?
Yeah.
So then it's position feedback.
Oh, position feedback for this hinge here and the belt.
Yeah.
Oh, okay.
Position feedback,
okay, and then maybe that's the magnet.
Yeah, that's what it is.
Okay. All right, so that's like the surface mount version of this thing.
Yeah, that makes sense.
Okay, so for positioning of this, so each of the motor axes has its own Hall effect sensor for positioning. That makes a lot of sense. But yeah, I think this thing is pretty well designed. Most of it's plastic. All these pieces at the bottom are plastic, and the motors are heavy and everything, but the neck of it is metal here.
I see. Oh, so it's nice and strong.
This is holding your phone.
Yeah, exactly. And also moving around
and
a lot,
also moving. Too. Yeah, and you want the camera movement to be nice and smooth.
Cool. This is a nice extrusion. Or whatever it is made of. How did they make this? Is this machined? You can see machining marks. Or is this like molded?
See.
I guess we should look at it under the microscope. There's no way that they machined this.
Yeah, but these are machining marks, right?
Yeah, but it could be machining marks on a mold. Oh, what else we got?
I think that's it.
That's it?
That's a lot. There's a lot of stuff going on, and there's like a ton of parts. And as far as like harvesting things, this has some harvestable parts. It's got this really cool battery. It has 2 really nice quiet stepper motors. A nice bearing, a slip ring. The slip ring is very cool.
The slip ring is great too. Yeah, the slip ring is real good.
So out of all the things we've taken apart, I think this has the most parts that we could reuse. But that makes sense because we usually take apart wearables, and this isn't a wearable.
These are really nice steppers.
Yeah.
Cool. All right. Well, great.
We did it.
We did it.
See you next time. Thanks, David.
Bye-bye.
If you liked this video, please give it a thumbs up and share it with a friend. I hope you'll subscribe with the bell to be notified of my future uploads, subscribe to my email newsletter, and find me on your favorite social media platform. Thanks so much for watching, and I'll see you next time. This video was made with support from my sponsors and generous donations from viewers like you through Patreon and YouTube memberships.